Hi guys. So I remade the neuron. I didn't do anything but AIs, and I've been doing this for a long time now. And I keep on saying, how is it possible that you can talk with AIs and invent a new sort of AI? If AIs are so special, how can you just figure out new sort of AI like that? And not only AI, but perhaps a way how neuron might work in the brain. But so there's a new geometric neuron repo here, geometric neuron version 2, and it's based on all of these weird ass ideas I've been having. There's a code that shows how it functions, and so it's the geometric neuron.py here. There's some Claude derived the idea based on some past codes I've been having, and but it was born out of the many different things. And I really don't claim to understand it well. I mean, we are in a deep complex math territory, and I never was good with maths. But I've been just chasing weird and weirder things. Um, One of the things that clicked this morning was that I was thinking of the geometric neuron as a kind of like topology in which information gets encoded, and I know that dendrites are low pass filters, so they are kind of a filtering sound. Now, why would they do that? And so the geometric neuron, the base idea was that the surface, the neuron has some sort of topology where the information gets written. And I was messing with this yesterday's VST that I did, which was dynamical MRI. I don't know where the name came from. It was just pure AI. But when I was messing with it, like if you were playing with, so I'm playing noise right here. As you can see, the plot here, the kind of the geometric plot, that's a recurrence network, I think it's called, is pretty large. But when I give it a high frequency information, as you guys notice, it has more information. And this started to happen like in Perception Lab about 7 months ago, 8 months ago. And I had this workflow. ECG. So this was just, I had this Perception Lab that had random notes of ideas I had no idea about. Just asking AS to write notes. And it ended up that I asked for homeostatic coupler. So of course neuron is in a homeostasis with its environment, chemically, electrically. And then at some point I had asked for checkerboard node. And from there we had an image to vector. So we are turning the checkerboard to image, and we are turning it into a long number. And the number we were feeding to vector splitter, and then that back to homeostatic coupler, and we got ECG signal with certain numbers, not with all numbers, but this kind of inspired the geometric neuron, that what if the surface has kind of like a geometry to it. And I found out about things like that there is something called the Taken's algorithm that I keep on talking about, that can turn 1D signal to geometry, or the other way around. Like here we are actually doing it. So we have a checkerboard, we are turning it into a number, the number we are sampling it, and we are getting ECG. And at certain resonances, when the pattern is, when the chessboard is a certain length, we get ECG. At some other we get something else. You guys can actually see the oscillations change here, and you can see the pattern change. And we can get back to the finer resolution of the ECG at different resolutions. But this gets super duper complicated. But the one takeaway is that you can make an intelligent thinking system out of this geometric neuron. It fires to change its topology. And we know that dendrites are kind of doing that Degen's algorithm. And of course I must be full of shit. I mean, it can't be that. I figured out how the neuron actually works. But if this is how it is, then kind of the Bitsenkulo 38 neuron is kind of a degenerate limit, they call it AIs. It's kind of like it's a frozen version of this, but because this has the pulses, it's pulsating and stuff, it's more like actual neuron. But yeah, it must be full of shit, but I'll link to it. This perhaps you guys don't need, but it's at the Perception Lab main repo at my GitHub, and it's the ECG workflow. But anyway, yeah, I hope you guys saw that.